This is for exercise 9.17 in language, logic, and proof. We'll be translating universal noun phrases. So let's continue. For number 1, all cubes are small. This is obviously an indication of universal quantification and the form of a conditional. So, and like it says in the textbook that sometimes students will mess it up and want to use for all x's, they would use a conjunct instead of a conditional, and you use conjuncts in existential quantification, not universal, when in this format. So it would go as follows for number 1. For all x, if x is a cube, then x is small. Number 2, each small cube is to the right of a. So whatever is a cube would happen to be to the right of a, and so is and are indication of implication. So you would use the conditional. So for all x, if x is a cube and x is small, then x is to the right of a. And notice, remember, it says small cube, so you need to predicate that as x is small and x is a cube, just as you would if you were to translate it regularly in some of the previous exercises. For number 3, a is to the left of every dodecahedron. So if it's a dodecahedron, then a is to the left of it. Or in other words, for all x, if x is a dodecahedron, then a is to the left of x. So for example, for all x, if x is a dodecahedron, then a is to the left of x. Every medium tetrahedron is in front of b. So for this one, again, so just as in number 2, you would want to include a conjunct in order to make the antecedent true. So it would be for all x, if x is medium and x is a tetrahedron, then x is in front of b. Continuing for number 5, each cube is either in front of b or in back of a. So for all, you would want to use this for all x. If x is a cube, then either, so get the disjunct, x is in front of b or x is in back of a. Try to pause as we go along, so you try to do it yourself and see if you get the correct or the same answer, or even if you do it and you end up with a true statement, then you know that you've done it correctly for the translation. For 6, every cube is to the right of a and to the left of b. So every cube, so it'd be for all x, if x is a cube, then x is to the right of a and to the left of b. So for all x, if x is a cube, then x to the right of a and x is left of b. Alright, number 7, everything between a and b is a cube. So it would look like this. For all x, if x is between a and b, then x is a cube. Number 8, so everything smaller than a is a cube. For all x, if x is smaller than a, then x is a cube. Then x is a cube. For number 9, all dodecahedron are not small. So what you would translate this is that for all x, if x is a dodecahedron, then x is not small, because it's categorizing the entire objects that exist that are dodecahedron as not being small. So in other words, there does not exist x, or does not exist a dodecahedron such that x is small. And you would translate this as follows. For all x, if x is a dodecahedron, then x is not small. You could similarly write this as there does not exist x such that x is a dodecahedron and x is small. And we will come up across one of those existential from a quantification in the next, or in a couple other extra examples. So for number 10, no dodecahedron is small. So that does not exist. For this one, you could write for all x, if x is a dodecahedron, x is not small, or similarly, there does not exist x such that x is a dodecahedron and x is small. For number 11, a does not adjoin everything. And the way you could write this is not only with universal or existential, but the way I would do it is existential. So you'd say for a does not adjoin everything, meaning that there exists x such that a does not adjoin x. So there exists X such that A does not adjoin X. Or, yeah. For number 12, A does not adjoin anything, which is different from saying the previous one. So, meaning that there is not, and that one was just an instantiation of one that would negate the universal quantifier. This one, on the other hand, is a instantiation of a universal quantifier such that, and you could similarly using equivalency use a existential quantifier. So for this one, it would be there does not exist X such that A adjoins X. So for this one, you could similarly write it as for all X, it is not the case that A adjoins X. So in other words, there does not exist X such that A adjoins X. And 13, A is not to the right of any cube. Okay, so in other words, there's not any cube such that A is to the right of that cube. And you'd write this as for all X, if X is a cube, then A is not to the right of that. If X is a cube, then A is not to the right of X. So for number 14, it would be if something is a cube, then it is not in the same column as either A or B. Now, this one is starred, so it's a little bit harder than the previous 13 exercises or examples. So this one, even though it doesn't have any sort of obvious instances of a universal or existential quantifier, either using some or there exists at least one, or there exists such and such, or all, or every, and so on. However, this is still an instance of a universal quantifier. So if I say that, if something is mortal, or if something is a man, then it is mortal, would still mean that for all X, if X is a man, then X is immortal. Just in the same way that if you would say all men are mortal, it's the same as if saying if it's a man, then it's mortal. So for number 14, if something is a cube, then it is not in the same column as either A or B. So it'd be for all X, if X is a cube, then it is not the case that X is in the same column as A, or X is in the same column as B. Now for number 15, 15 states that something is a cube if and only if it is not in the same column as either A or B. Now this one has a sort of a trick of appearing as an instance of existential quantification, but it's or quantifier, but it is not. Notice that something is a cube if and only if. So is a cube. It's not saying that there exists a cube such that ... rather that something is a cube, meaning anything that is a cube is a cube if and only if it has the following conditions. And so you wouldn't write this as there exists X such that. You'd write this rather as for all X, X is a cube if and only if it is not the case that X is in the same column as A, or X is in the same column as B. And hope this has helped. Here's another here's it all together if you need to see it again. Now you could write some of these ones with existential quantifiers as in a different way, and you could try it and see if it works. If not, then you need to fix it and see what you did wrong. But it shouldn't be too hard. You should be able to do that. And remember that when you're using a universal quantifier, you'd want to use a conditional, and when you're using an existential, you usually would want to use conjunction. And some will get it wrong, and you want to use a conditional when it comes to an existential quantifier, and that's not what you want to do. You want to use a conjunction. So remember that whenever it's an instance of existential, usually you would want to use a conjunction. For example, if I would say that some people are red, then there would be an instance of a conjunction. It wouldn't say that there exists X such that if X is a person, then X is red. No, it would be there exists X such that X is a person and X is red. So this concludes the exercise number 9.17. I hope this has helped, and there's another peek if you need help with it, and just hope this has helped. Thank you.